Hello, everyone. Thank you for joining this session on the Lightning Talks as we wind down the main Apricot conference. So the Lightning session for those, Lightning Talk session for those who don't know is a 10-minute presentation that's, interesting, fun, quick. We're making room for Q&A, so if you can keep it to 8 minutes, so there's time for people to ask you some questions, that'd be great. We need to get through a lot of talk, so 10 minutes is just about all we've got. So in somewhat no particular order, let's say, lots of the speakers are in the room, so I'll just ask them to come up to start their talks. The AV team will have your slides up. The clicker is over here, and we'll use this microphone for everybody. So first up, we'll have Husni to come and talk about equipping students with BGP skills.
All right, good afternoon, everyone. I'm Husni from SoyAsia. Today I'm going to talk about our program, and one of it is we want to equip students with the BGP skills. We're from Research and Education Network community, and our main target here are undergraduate students. And the reason why we want to do this is because we want to have students really learn about the internet. That's why we have the internet in the name of our program, and this is the way we say it, okay? This is a simple model of the internet, looking into the typical data flows that is flowing from data center or hyperscaler through the carrier, ISPs and IXPs, and then going to the eyeballs, the enterprise, campus, and the home SME. We're not touching the home. We had our program in the IGP and switching, and now we're going into the BGP and Wi-Fi as well. But in this audience, the context is a BGP. Because for us, the operators, internet is to a BGP. For users, internet is Wi-Fi, right? So this is what our program is. We name it API, Asia Pacific Internet Engineering Program. So it's not network. So that's why we want to include the BGP there, because we understand that the internet entails coordination between networks. Okay, we do it in the self-paced online with the BGP fundamentals, and we have the e-workshop. This is a real-time component using Zoom or Google Classroom. This is where we do the recap as well as the quizzes to measure their understandings. And if they pass that, those programs with flying colors, they go into camp. We have a 5-day camp, and for this BGP, it's a 3-day camp. It talks about multi-homing, transit, exchange point, and spine and leaf for the data center. And we put the students in groups, so they have to do group tasks. And at the end of the program, they have to do a presentation, right? So this is an example of exercise, final exercise that they have to do, okay? If you're familiar with the Mininet, okay? The Mininet, if you see the GitHub, it's been inactive in the past 3 years, but our team, we extended the Mininet, okay? It's not public yet, but we plan to do so later, after this is stabilized. And the good thing about this is that it has a GUI like this. So this is the topology. So the students in groups, they have to configure the routers, the ones in blue circles, right? And the ones in the greens, these are the hosts for to do pings and trust route, iPerf, like this. And this is all container-based and using FRR as the routing software, okay? And the ones on the top, those two things, the TR1 and TR2, these are EXA BGP. So we use EXA BGP here to advertise prefixes. So we can advertise random prefixes. We source this from BGP dump. So sort of we can think of it as a simulation of the internet. It's just that depending on the scale of our hardware, the capacity, we can do 1,000 prefixes or 10,000 prefixes. It depends there. So the students in group, they have to configure all the blue circles, the routers, like the upstream, the customer, as well as the XPs, right? And then they have to present their configuration and explain to the faculty members who see their presentation. So this is how we do it, and we hope to engage with the community, especially the operators, so that we can give more exercises, samples, and we can do this starting probably the end of the year or next year, because this is just a pilot at this moment. And then with that, where's the slide? It's empty? Nope. No slide. Well, thank you. The lead of EPA is there, Kudo. And we made this with the collaboration of our partner in the Universitas Brawijaya. Thank you very much. Questions?
Thank you, Husni. Any questions for Husni?
Everyone's good. Thank you very much.
Awesome. Thank you. Right. So next up, we should have Yolandi talking to us a little bit about simulation.
All right, so my talk today is focused on simulation, of course. And the reason I decided to present on this topic is because I was curious to look into how can we tap into the younger generation to become more curious about what we do in network engineering. So I started looking online to see if there is something that exists that could potentially inspire the young people to get into the industry. So as we know, I mean, we've been talking about this issue since, quite a few years, over 10 years, talking about not having enough network engineers coming into the industry, right? And, the past, I would say, 3 to 4 years, we've been talking about the great retirement of the network engineers, the existing network engineers, and not having enough people to fill those roles. So this got me wondering, what is it that we can do to actually get more people interested in what we do, right? And one of the things I thought about is that the way I got interested in what we do is to actually have that experience to do something, right? To just read a book, just a few words about engineering, configuration, and all of that. Yeah, it's good, but it's not really inspiring. It's not that interesting. So what else can we start looking into? So then I thought of the idea of simulation, right? So when I say a simulator, if you can build some kind of simulator to simulate the environment within a data center, this is not what I mean. And this is exactly what we often see is the two-dimensional network topologies that we see in books and online, right? This is not enough, right? What if we can make it more interesting? What if we can make it more interactive? So I thought, there's a lot of games that exist in simulation. And from what I've seen, a lot of people get addicted to these things, right? Like lawnmower simulator, how to cut grass, right? I have seen people spend hours playing this, right? And you learn weird things when you play simulation games. You start to understand the different type of grass that exists, the different type of motors you can use for the lawnmowers, the type of lawnmowers you need for the area of the lawn. The same with Power Wash Simulator. Again, random, useless skill, I would say, but people enjoy doing this. So this got me thinking, what if we could do something like this for networking? What would it look like if we had some kind of simulation to show them what it is to be a network engineer? And there are a few things that exist, and you might be familiar with some of them. Some of them are quite old. So the first one is Cisco Aspire Networking Academy Edition. This thing is very old. I'm not sure if it still runs, but it did exist. In 2018, a group of students actually created a game called the ISP. And basically, it's a two-dimensional game which allows you to create a network topology and see how the routers and switches connect as you create the interconnection between the different points. Then I came across what is called the Network Engineering Simulator. So there's actually someone out there that is thinking the same way I do. What if we can simulate the environment that we work in to show people what it is that we do? And this is actually available on Steam, and people are starting to play it. I mean, it's not a full game as yet, but I found it does exist. So what is the goals that we want to achieve with the simulation? To make networking interesting again, right? To show people what it is all about. It's not just configuration, a two-dimensional thing that you see in books. It's an actual thing, and it can be fun. To teach the basics of networking, so to simulate what it is to do troubleshooting, to do actual configuration, to do patching. Simulating real-world environments. Imagine in this game, you can actually simulate your ISP connection going down. And you now have to figure out how you can get internet to your little town within the game, right? So actually bringing in some issues that the player needs to resolve. And modernize and visualize. So technology exists to actually make this interesting, to make it real, to make it feel as if they are in that environment and really see what it's all about. So this is supposed to be a video. It's static, unfortunately, but this video shows you what it looks like in-game to actually play. And in this video itself, what you need to do is actually connect your you have to do your patching and some cable management to connect from the one cabinet to the other. Once you complete that, you actually have to take a note and then start configuring the switch to get the lights on and get the connection established. So this is just an example of what can be achieved with this game, and I think it's quite cool. The cables is quite funny because when I did this video, the cable was like a little piece of spaghetti, so that makes it a bit challenging to do the cable management. But what the guys have created here is really the foundation of what could be a great, inspiring way to get network engineers from our new generation. So imagine playing this game and having like a quiz come up, asking the player to choose their path going forward. So the client is experiencing an issue with their internet connection. How do you respond? Now the player has to choose how they would respond. Number one, have you tried rebooting? That is obviously the default that you need to respond to first. I suspect your internet is just playing hard to get. This happens quite often. I don't know about you, but I've experienced this quite a lot. Is the router's I'm tired light on? So of course, this is just a joke, but this could be somehow how you can engage the player to learn as they are playing, right? To give scenarios and see what it is, how they would respond, and based on the selection of their response, it has an effect on, the network. So perhaps they say troubleshoot a link or change the configuration, and based on that, the game then responds accordingly. So the Cisco Aspire has done this, and as you can see, it actually gives you tasks to do, because this is a two-dimensional game where you need to get a network up and running, but it gives you tasks and it gives you steps, right? So this is a fun way to try and get your network up and running while learning how to do so. So this is kind of the idea behind it. So if we can take this and actually make a more modern version of this, would be fantastic. So just a little bit more about the network engineering game. This is a 3-person company, and they were founded in 2019. So it's 3 engineers that came together to say, how can we make network engineering cool again? And the result is, of course, the network engineering simulator. It was actually brought up as a joke, as you can imagine, and 3 of them thought, you know what, we are going to do this. And as of today, there's actually quite a lot of downloads on this game, people playing around, and a few updates have happened. So I do encourage you, if you just want to have a look what it looks like, please do download it or go watch some of the videos that exist of the game. It is actually quite funny. And then future plans that the guys have is a creative mode. So this mode allows players to roam around and provides a more educational experience. So you can go out as a player and try and build a network. So for instance, you might have a neighborhood where you need to get internet to. So it's up to you to plan out a network. And then story mode, if you are not the creative type and just want to learn the basics and first want to experience the story, you know, starting as a network engineer, having to configure a LAN, and then going into the FTTH mode, and then progressing as you go along. So that's kind of the plans they had. I thought this is quite cool, and I would encourage you to check it out. And if you have any comments, suggestions for this team, here is their contact details if you want to reach out and share some of your thoughts on this. And that's me. Thank you so much.
Thank you so much, Yolandi. Any questions for Yolandi? On the simulator? Yep. All right. Thank you so much. Next up, we'll have Christoph talking to us about comparative analysis of the IRR landscape.
Hi, I'm Chris, and I'd love to talk about analysis we've recently run. It's about a comparative analysis of the IRR landscape. And basically, this is a cooperation of DKIX, AMSEX, and some other folks. I have the list of contributors right at the end. So why did we do this? We were working on a B Corp proposal with some colleagues from AMSEX. And actually, one of the statements we wanted to have in there was whether IXP operators must only rely on real IRR databases, so the authoritative ones for route server filtering. And while we stumbled across this, we understood the implication that this might require a massive transfer of RPSL objects, right? And then we reached out to the community and were asking them what their thoughts on this are. And basically, the collection of feedback was that indeed they are using a lot of third-party IRR databases. And if RPKI is there, it might be the option to move forward and to just let the problem solve itself. And what about the legacy space, which is non-transferable or as in hard to transfer? And to address these concerns and also move forward, right? So migrating to RPKI, retiring some of the third-party IRR databases, this is essentially about this, we need to have a better understanding, right? If you want to move in the future, you need to get a better picture of the current state. And that's what we've done with this analysis. And I just want to share here some highlights with you. But I also link 2 reports where you can really drill into all the nitty-gritty details of this analysis. They're basically 2 RIBE Labs articles about it. So here we are. Where are the objects stored? And for simplicity, we actually classify into route objects and ASZ objects. And we actually looked in all of the IRRs you can see at the x-axis there, right? The authoritative ones and the so-called third-party IRRs. And if we count the objects that exist and look at the representation, the share of it, we actually see that the routes are, or most of the routes, like 30-something%, are at RADB, right? And at AppNic and RIPE, there are also many, but not that many. However, AES set objects, most of them are stored in the RIPE IRR database. So another finding is that the smaller ones, there are many smaller ones, third-party, and also smaller ones, authoritative, that their share overall is neglectable. So it's less than 1% of the global objects that we can find in the 10 smaller ones. So that said, we also need to find a way to measure actually how well maintained they are. And so we actually looked at default free zone alignment. We understand that this, from a networking perspective, is not a hard requirement, and that there are good reasons why you won't have an alignment. It might be that you created the objects for future use. You're currently in the process of deployment and have other considerations. However, we thought it's still a good proxy to understand how accurate these are. And therefore, we actually looked at 2 dimensions. We looked whether the origin is not equal or equals the default free zone origin. And we actually looked on route objects with no routes in the default free zone. And as a percentage, that's the 2 axes. And we plotted now all the IRRs, and the bubble size here indicates the size of the objects. And the orange color depicts the authoritative ones, and the blue ones is the third-party ones. And the clear winner here is the TC. And it has just 1% of misalignment, and 1% of their route objects have no route in it, in the default free zone. However, if we look at all the other third-party ones, that is also really the big ones, we see that nearly all of the third-party IRRDBs have a worse alignment within the default free zone compared to the authoritative ones. So if we look at this metric, we clearly see that the authoritative ones perform much better here. So next, we actually looked at the data quality assessment via consistency metrics. And therefore, we actually looked at all the objects from the different databases, and we have grayed out the authoritative ones because, and this is just a count, we don't have these classes there. And we looked at primarily RADB because that is the biggest by far. And we see the different classes of conflicting ones. So we have conflicting with RPKI or authoritative ones, or conflicts with the announcement that we observe in the DFZ. Then we have duplicate ones or irrelevant, so it's the same group, and same covered with RPKI, there's an authoritative IRR for it, or we have seen it in the DFZ. And if we look at the distribution here, we see that of the 1.15 millions, 1 million, which accounts for 84% of the route objects in our ADB are conflicting ones or duplicates. However, the ones that, if we want to deprecate all the third-party IRRs, is the 16% relevant routes that would be vulnerable if they would not be covered then anymore by any of the sources. However, if we look at the majority of the third-party IRR databases, we see that basically the impact that it would have if we would deprecate the usage for the route server filtering at IXPs is at large neglectable. However, there is more details to it, and if you want to read this up, it's the 2 mentioned articles here. So the first one is more as an intro and getting an overview, and the second one is more looking at the consistency assessment, which ones are the good, the bad, and the outdated ones. And basically to move on, what do we do next? We want to really do a simulation, because it's easy to say, look, for some of the IRR third-party databases, there's just a few objects, and that is not a huge problem. However, that could practically still mean that it's a lot of work, or it could really screw up things. So therefore, we want to run a simulation where we see what-if analysis and see really what the practical impact would be. And in the future, of course, we want to explore whether we really can substitute the non-authoritative or the third-party IRRs with RPKI or the authoritative IRRs altogether. So thank you. I hope I could share some of our highlight findings here. And as I said, if you're really interested, check out these articles. They're well written. And really a big thank you to the team of guys who run the big data analysis, set up all the plots and the writing together. Thank you.
Thank you, Christoph. Any questions for Christoph? I think we have one. Name and affiliation, please.
So thank you very much, Chris. So one question so first Arnold Nippe from DKIX. One question, as far as I know, network operators are able to register their, let's say, asset or route objects not only in one database.
Certainly.
So
yeah.
what's the reason for them not to register their objects in an authoritative one?
So that has multiple reasons, and some of them are also the history. So RADB, for instance, was around actually before the authoritative ones got started, so historic reasons in that sense. But also sometimes that you can't really maintain the object if you have IP space from another region, and it's not a non-transferable object, so that could also be a reason. Then you just register it elsewhere. And operational procedures. So the barrier, the entry barrier to register it elsewhere is super low for the third-party ones. Actually, the checks they are doing and the plausibility test and stuff like that, and the account management might be also much simpler. So there are reasons, but mostly historic or operational reasons, or things we don't know.
Yeah, but for the network operators, they could register it in an authoritative one. So wouldn't be a good approach to educate the operators to do so?
Yes, so that's a part, to some extent, why I'm standing here. So we saw the 200,000 that are not covered from any other source in RADB, for instance, but it's the same distribution among the other IRRs as well, even though the total count is smaller. But yeah, for us now, it's pretty easy to say, okay, these 200 need to be just registered in other ones as well. We have no means to understand what the operational impact and the manpower is that's needed for that. But clearly, that is a call to start looking into whether it would make sense for you or your network to actually register with your IRR, your authoritative IRR.
Okay, thank you.
Thank you so much.
Thank you.
Thanks, Christoph. Next up, we'll have John giving us his insights into the Indonesian market.
Hello. This is more about playing with tools than it is about the market. But anyway, I'm John. I'm from New Zealand. I work as a network engineer, and I'm also on the board of APNOG, who puts on this conference. I wanted to know quite a bit about the Indonesian market for a few reasons. And the first place I went to look was Jeff Houston's customer population estimates for Indonesia. And this is great. Thank you, Jeff, if you're in the room. It's great, but it doesn't quite get all the way there because it measures customer populations by ASN. And of course, commercial entities often have lots of different ASNs. In this case, this is just a few, just two. We've got XL Smart there, and that's just some of XL Smart's ASNs. And we've got Telkom, and that's just 2 of Telkom's ASNs. So how do we fix this? There is a new tool called Borges that I read about probably on the APNIC blog end of last year. If not on APNIC blog, then on LinkedIn or something. And it uses LLMs to go out on the internet and find how ASNs could be commercially related to each other. And it is pretty cool. Here's a picture of the beginning of the paper, Learning AS to Organization Mappings with Borges. And on the last slide of this presentation, I've got a link. So it's not perfect, but it is a good start. So with the output from Borges, I went and did a little bit of a manual cleanup. And as you can see in my screenshot there, I had to go with the Australian market, the Malaysian market, NZ, Philippines, and US, and Indonesia. The US is just incomprehensibly large. Philippines, I've been working with for a long time. Anyway, Australia and New Zealand, I kind of know even without looking. So I wanted some more data about the Indonesian organization, so I went and used APNIC's RDAP server. And I just pointed Python at it, and I pointed the ASNs at it, and then I was able to get some information about where these ISPs were located. And it wasn't perfect. Why isn't it perfect? Just because of how the data is stored. If we see in there, I've highlighted down at the bottom the address label in the vCard for the object, the JSON object that RDAP sends back. Not everybody puts their address in that particular object, and not everybody formats their address the same way. This is a problem. I don't know, maybe one day we'll solve it, but all of Who is a disaster. Right, so I got that, and then I wanted to see what does the transit market look at, and again, I found a very cool project online. I don't know if this was by the APNIC blog or LinkedIn. Again, I see these guys sitting in the room. Yes, hi, I'm sorry for breaking your server a few times. So I said, oh, right, I think I'll have a go with this. Didn't have a lot of time, so I kind of sat there and pointed my own LLM tools at my code that I had already for other things. And I said, hey, can you go out and get me some market data from this API? And 2 million results returned later. I had a whole lot of AS paths from France to Indonesia. Pretty cool. And look, if you look at the end of that, that's actually these numbers, that 4.8923 blah, blah, blah times 10 to the -6. That's the eyeball data from Jeff Houston, which I've mapped to that ASN. Anyway, so my results from this in descending order, Telkom, XL Smart, LinkNet. LinkNet's in there twice. And in fact, LinkNet actually is like 60% owned by Axiata. It's a really complicated market here. But Cogent, Tata, F5, 1299, whatever they want to call themselves this week, BizNet, Hurricane, NetIX, Telecom Italia, and Cloudflare. And so what the heck are Cloudflare and F5 doing in transit providers? And it turns out, since I just sent a message to Tom at 2 a.m. his time, when he woke up, he said, oh yeah, we're providing scrubbing services for them. I imagine that's what F5 is doing also. So there is a way for me to take them out. I haven't done it yet, but as we can see, this was my own analysis I did with RStudio in R. When you have a spreadsheet, a CSV that's 2 million lines long, you don't open that in Excel. No, you open it in RStudio, because then you can actually work with the data in a couple of seconds. We have BP Singapore, Oracle, BizNet, XL, Prima, Politnik, and Telkom University. Oh, I bet they're both in Bandung there, who are taking Cloudflare for scrubbing services. Right. And then I went to say, well, what does it look like? So I've actually made an eyeball-weighted Sankey diagram from tier 1 carriers to target market carriers. And you can't do this with all like 1,400 ISPs in Indonesia that have eyeballs because it just breaks your computer. But you can do limited sets, and you can see really neat things like where's all the data. One of the things that complicates any BGP analysis is this company called Hurricane, and I don't know if Walt is in here, but anyway, Hurricane's basically in everybody's path. So at some point I might do another analysis and just kind of hide them. But that's it for me. Here's a set of links to the tools I used. APNIC Labs, Python, Borges, BGP routes, thank you guys. And Crystal, who's not here, APNIC's RDEP, our desktop, and the Sankey diagram was done with Plotly. And I have a question, please.
Jeff Houston, APNIC. I'll be quick. You used an AI tool to try and get a mapping across from AS and IP addresses into the real organization. The RIRs kind of help you and don't help you. In the daily stats file is actually a field called the org ID. It looks like ASCII noise, but the same ID is there for the same customer. So if I know an AS and I look up that extended stats file, I take that org ID and then I look up all the resources against that org ID, I know what they have. What's missing is the name of the organization. I now publish a file that says this is the organization name that has all these resources in the daily stats file. No need for AI, no need for large language models searching, which will get rid of one of those things you're doing. The third bullet, learning AS to org mapping, or at least I'm now publishing that straight away. That won't make your life that much easier, just a little bit.
A little bit, thank you. All right, and my time is up and I'm in the negative. All good?
All good.
All right, thanks
right.
all.
Thanks, John. Next up, we'll have Arnold talking to us about authenticating networks with RPKI RSC.
Yeah, good afternoon. So I'm Arnold from PeeringDB as well. And what I would like to talk about is authenticating networks with RPKI RSC. So the table of contents is what is RPKI RSC and how we will use it for PeeringDB. And the next question is, should we add more features? So actually, what is RPKI RSC? This RPKI RSC, this stands for RPKI Signed Checklist. And actually, this is a technology to, for resource holders to sign arbitrary files or documents if you have an internet resource. That means if you are a holder of an IP address or of an ASN. And what we want to do is to use this technology actually for registering your ASN in PeeringDB. So in PeeringDB, we are using GitHub for using new feature requests, and Job Snijders already had this feature request 3 years ago, where you said, okay, please use RPKI to verify networks and IXPs during sign-up. And with RSC now, it is possible to do that. PeeringDB, with its release in March this year, will use RSC, and I'm standing here because APNIC actually is the first RIR which support RSC. So the questions I have for the audience or anyone in the APNIC regions is, Do you want to know how networks authenticate it? That means, should we have a field in PeeringDB which also says, okay, this was authenticated via XYZ, let's say via email or IRC, and so on and so on. Next is, do you also want to know when networks authenticated, that it has a timestamp or so? And also, do you want support for periodic re-authentication? That resource holders not only do it once, but also have to re-authenticate in a time period. So to get engaged with PeeringDB, either use our GitHub or one of the different mailing lists. If you want to talk to us, Yolandi, who has been on the stage a couple of minutes ago, is over here, same as me. I will be here until end of the week. And I guess that's it. PeeringDB, just to let you know, if you are not network operator, IXP, if you run a facility and you are not in PeeringDB, there's something wrong. You have to be there, and the use of PeeringDB is for free. PeeringDB gets its monies from sponsors, and everyone is really invited to sponsor PeeringDB because the information from PeeringDB helps all of us to run the internet. That's it from my side.
Thank you, Arnold. Any questions for Arnold? That's it. Thank you. And staying on the topic of our PKI, we'll have Ying Fei talking to us about ROA issuance.
So hello everyone, I'm Ying Fei from CNNIC, and this is my first NIC meeting, so please be kind if I sound a little bit nervous. So let's begin. Today's topic I want to share is best current practice for ROA issuance restrictions. So the background is that we see NIC now is encouraging the RPKI deployment in China. Yes, we are working on it, and we have built our self-hosted RPKI system. So during this process, we noticed one thing interesting. You may know there are many large enterprises in China. There are large ISPs, there are large CDNs, and they have many independent child companies across the provinces in China. So the problem is that both the parent company and the child company seek the independent control over their ROAs. So what should they do? Should they still use the same CA for the parent company and the child company, or should the parent company use the parent CA and the child company use the child CA, use this parent-child CA model? So while we are discussing this, we notice one thing, that if we use the second plan, this parent-child CA model, it will introduce ROA conflicts because there is no restrictions that prevent the parent CA from issuing ROAs for some delegated resources. So it has some consequences. It will cause security risks, and it will cause ambiguous validation. Here are some cases. First, that if a parent CA sends ROAs for some delegated resources, but the child CA doesn't, and still the child CA announces those routes, those routes will be invalid, and it will cause a routing black hole. The child CA's routes will be invalid. The second case is that if the parent CA is controlled by attacker or villains, it can hijack routes easily. And the third case is that if the parent CA and the child CA sign ROAS for the same resources, but maybe with different content, different AS number, different max length, the real party will be confused. It doesn't know which ROA to believe, which one is right. We also performed some data analysis. We found out that there are 29 CA certificates shows resource intersection between the child CA certificates and the parent level ROAS. Like the red circle and the blue circle, there are resource overlapping between them. So this means the situation I mentioned does exist, and the security risks does exist. Therefore, here's our suggestion. We suggest that parent CAs must not issue ROAS for resources that have been delegated to a child CA. This is not allowed. And RPKIC software should do something, try to prevent this to happen as well. And also, since the resource allocation follows the tree structure, we also suggest that only leaf CAs can issue ROAS, and the non-leaf CAs are not allowed. This can prevent the risks I mentioned before. Also, the relying party should make some effort too. If a non-leaf CA issues a ROA, RP software should trigger a warning during validation. Then you may ask, what if I'm a parent CA and I want to sign ROAS for the resources I directly host, but I'm a non-leaf CA, then I can't sign it? So our recommendation is that for parent CAs that want to sign ROAS for the resources it directly holds, we suggest that parent CA should create a dedicated subordinate CA and use this subordinate CA to sign ROAS for the resources it directly holds. And back to the question at the beginning, which you may forget, it's the question about what should large enterprises do if they have many child companies. Our suggestion is that the parent company and the child companies in the same large enterprises, they should use the shared common CA, use the same CA. This can align with the principle of least authority in the global RPKI system and reduce the risks I mentioned before. And the separation between companies can be done in the software, but not by separating the CAs to the parent and the child CA model. So that's all, thank you. We have submitted the drafts to the IETF SetRops working group. So if you are interested in it, please share your opinions, and all feedbacks are welcomed. That's all, thank you.
Thank you, Yingfei. Any questions for Yingfei on this proposal? GGM, I see you want to put your hand up. No? Okay. Thank you, Yingfei. Next up, we'll have Adli. There we go. And Adli is going to talk to us about botnet tracking with honeypots.
All right. Hello, everyone. My name is Adli Wahid from APNIC. So today I'll talk a little bit about some of the work that we do with the HoneyNet project. So the plan is to briefly talk about the HoneyNet project, and then I'll discuss how we do the botnet tracking from the HoneyNet data. And maybe I'll discuss a little bit about threat sharing and monitoring. And quickly on the APNIC HoneyNet project, this has been around for a while. Maybe some of you are familiar with it. In the last few days, I've spoken to many people about it. We have currently about 500 sensors in different places. And the idea of the HoneyNet, for those who may not be familiar, is that because there are no production value in the honeypot itself, anything that comes to it is suspect. So we get a lot of connection or attempts to get into the honeypots from mostly compromised devices or botnets or malware and things like that. One of the immediate value of collecting data in this way is that we immediately identify potentially compromised devices. And with that information, then we can notify the network operators of the certs in the country or the region so that they can do some remediation or take some action. However, the honeypots is a bit flexible in terms of not only it is just looking at the connection, but it allows some interaction. So a lot of the honeypots that we run are medium interaction honeypots, which means that if you try to log in, then we will let you log in, we'll give you a fake shell, and then you can run some commands on it. And what we are looking for is, if this was a botnet or some malware that is trying to spread, then it will try to download the payload. And from there, we can see other compromised devices or the attacker's infrastructure where they are hosting the malware and things like that. Anyhow, so in this particular case, maybe it's too small to see. You can see that not only you have the connection attempt with various username and passwords, and the whole thing that is important on that on the slides there is the wget command, where we see where the binary I is hosted. We can then download that piece of artifacts and do further analysis with it to get the bigger picture. All right. So the honeypots that we run may not see the most advanced attacks like ransomware or targeted attacks, but we get a lot of the botnets that are doing DDoS attacks, crypto mining, or maybe trying to recruit additional hosts for running residential proxies and things like that. So we get a lot of that information, and on one hand, actors that are doing this, they have no option other than to actually scan the internet and get into other hosts, right? So the honeypot is just waiting for them to come in. And a lot of them are really noisy, and they're not very targeted in terms of spreading and things like that. So we pick up a lot of these things, all the time. And the standard TTPs that we see is, spreading through SSH, Telnet, web. So we have a web honeypot as well that is doing this. We let them execute some commands, of course, in a safe environment. They will drop a shell script or binaries. So we keep that in storage, and we do further analysis with it. So this is a very good source of collecting a lot of information. So while the immediate work is remediation, which means that we share information with other people who we have seen their hosts connecting to the internet, the other piece of work is making sense of the data that we're seeing. So from the binaries, from the scripts that we collect, then we can see whether or not this piece of botnet is spreading, is it slowing down, is it being reactivated? Is it moving to different places in terms of where they're hosting infrastructure and things like that? And that piece of work is not just based on our data. We also use other resources from other certs and other threat researchers, which I will discuss in the next slide. So this is just a quick example of Mozy botnet. If you are in this space, maybe you have heard about this particular botnet. It's a peer-to-peer botnet. It goes on and off every now and then. In fact, we heard that the person who runs this has been arrested, but the botnet is still active. In this particular case, the botnet was very quiet for the first 6 months, and suddenly it's back in action again, right? So, and we see this trend every now and then, so we know that, okay, Mozy is back, and we get to see if it's using some new binaries, or it's an old one, or if it's, it's active in certain regions. So in this particular case, a lot of activities in China, Pakistan, Indonesia, and India in the last few months. All right. So a lot of this analysis is based on the artifacts that we collect. So we have a simple sandbox that we run in the back end, and we get to see a lot of other information. But the most important work here is, for example, when you have the sandbox, then you get to see other infrastructure-related information. So, for example, there's one piece of botnet where you can see that it is still using traditional IRC for communication, and that's the domain that it is using, and it has a .id. I just thought I'd share that because we are in Indonesia today. So the last bit of that information, of this work is, like I said earlier, that we have a lot of data, but to see the bigger picture, we have to do some correlation with other data sets. So there are a lot of other resources for this. So Shallow Server has a large piece of data sets, and we get feeds from them. A lot of the security teams or security researchers, they use MISP, the MISP threat sharing platform. We use that, and from there we can also do a lot of correlation. So one thing, for example, you want to see if this activity is seen in other places, or are we seeing the same data that we have in different parts of, of the region from the feeds and things like that. When it comes to the artifacts, Malware Bazaar is also another good resources that we use to see if the binary is brand new or it's an old thing. When was it first seen? When was it last seen? Is it detected by antiviruses and things like that? So there's a lot of that piece of information that can be collected. And the good thing about all this information or platform that is available out there is you can just use API to do a lot of the automation. So it's not manual work anymore like back in the days where we have to do analysis on each platform manually. So the last screenshot that I'm showing you here is this is just a GUI from MISP. So basically, if you get all the data in one place, then you can do some quick correlation with other data resources or other work so that you can have a better idea of the activity of a particular botnet. What is it doing? How big is it? Is it still active or is it dying? Has it moved to different infrastructure? So there's that piece of work within the HoneyNet project. If anybody is interested to learn more or to collaborate with us, you can find me. That's my email address. And that's it from me. Thank you.
Thank you, Adli. Any questions for Adli? All right, thank you. Next up, Samajit, talking to us about the challenges of ISPs and operators with being blacklisted.
Hi everyone. So my name is Samajit. I am from company Jali. So today's my topic is that this challenges for ISP for telecoms. That is IP deny list. So the first, just give an idea about why IP deny lists happen and how banks and government use this deny list, and that is steps to prevent or resolve deny list issues. So these are the reason that why there is many reasons. So here the why IP get denied list. That is the first is the bad reputation in the trade database. The second one is the phishing attack is one of the reason. And that is bottleneck activities, spam email sending, and poor email server configurations, malware and virus infection with CNC, and brute force attack is newly happened. I have seen the last 6 months, brute force attack is so much happening due to the cryptocurrency, and DDoS attack is also there, and hosting illegal content, and excessive failed login attempts. Spam effect on telecom and ISPs, that is, few mobile apps are not running, and if his IPs are in deny list, email deliveries issues are there, this is very old, and customer complaints are there. Higher risks of cyber attack. So if there is DDoS attack is there, there is a deny list in your network, and that is, and banking portal restrictions and web traffic restrictions. Brute force attack effect on telecom and ISPs. So due to the brute force, so there is a network congestion is there, and compromise user accounts, data breaches, and higher cyber security cost is there, and customer complaints, and service downtime is also there. And recently I've seen that brute force is also consume lot of internet. So that is consuming a lot of internet bandwidth also. So I've seen that one ISP using 40 gig of traffic, and after I realized that after 40 gig, ISP from India, so the 10 gig is brute force attack. So this is happening. It's not same for all the ISPs. So now what is the main is RBL. The RBL is that is, we call this a real-time backhaul list. And there are 50 plus RBLs are there globally. They are monitoring everything. And few of them popular, you know that that is Spamhaus is there, and Barracuda is there. There's a popular RBLs there, RATPTR. Those are very popular. And so what is their role? The role is that is blacklist database. They're maintaining this one, their network security, email filtering on traffic behavior, and reputation management of the IP, and DDoS and botnet protections, automated blacklisting and delisting is there. How does IPs are denial list by the real-time backhaul list? Because IP are added to RBL denial list when they are observed sending spam, malicious traffic, or violating the network policy. So these lists are then shared with the mail server and security system to block or filter risk IPs. So why banks and government block denial list IPs? Bank and governments blocks denial list IPs to protect money, accounts, and data, and system from hackers, fraud, and cyber attack. And the bank get all this data from the RBL. So, and maybe RBL and also from the local body is there, security body is there. It's different from the country to country. So, but banking system now, this is the first level of security for them. So they are to block those IP which are denial list, they block it. They're not allowed to open it. So that is the best policy. So what I observed that this is best policy for ISPs and telco to reduce the denial list. So filter the port 25, 587, 465, and 2525. And maintain the proper reverse DNS PTR record. And the other one is protect network from brute force attack. Thank you. I have a small presentation.
Thank
So
you,
you have any
Samajit.
questions? Yeah.
Any questions for Samajit? Yep.
Hi, Matthew from LeapTel ISP in Australia. We had similar issues to what you were doing, and I'm actually quite pleased to see that we ended up with very similar strategies. For us, blocking port 25 outbound, especially on our carrier-grade NAT customers, solved 99% of my issues. The other trick that I had...
You see that in my slide.
Yes.
So I already mentioned
yes,
here.
I'm just pointing out.
So
It's
I'm talking
really-
about the port. It's not actually. If you see that last 1 year, is only you the block the port 25.
Yeah,
But
only
scenario is changed now. But now you think that who is your spammer? Who is spamming? It's not a customer. It's CNC. CNC is the spanner. The spamming and generating the spam in your network. And so you have to take care of the 587, 465, and 2525. Not even that. First you check that one. After that you check the port for brute force. That is 21, 22, 23.
I'm glad that mine was simpler, that worked for me, but I'm glad you found some other things.
You connect with me, and after that my mail ID is there.
Yeah.
So I will suggest you what to do.
Yeah, the other thing I was going to suggest, which worked for us, and I did it by accident, is that you mentioned reverse DNS. Reverse DNS has a major impact.
Yeah.
And you were spot on.
Yes, real DNS is one of the main, one of the reason of that one. So, there is a RBL that is a RATPTR. RATPTR. So this is the main thing, and even the UC Protect. So you will see that your reverse DNS is not good. That also IP is listed there.
Yes. And one thing I found that helped is that we changed the reverse DNS of all of our residential customers into a different domain from our servers, and that way the list didn't block the servers that we actually wanted to send mail out legitimately. And
blocking
it worked quite
is,
effectively.
I tell you, blocking is not the solution. You have to monitor. You block it. If your network is small network, and you can block it. But if your network is big, how you manage?
how are you going to manage it when you're the size of Telstra and you're trying to manage it for millions of subscribers?
You're from Telstra?
No, I'm not.
So I'm talking about Telstra, you said, okay.
No, but if I've got several million customers with each one has 30 devices in their house or more, how are we supposed to monitor and effectively deal with it if you're going to monitor and deal with this?
So actually, it's a monitoring that we have to monitor it. The port 25 is, I told you that. You have to monitor, you cannot block it. If you block it, okay, if your network is very small, you can block it. But if your network is very huge network, it's very difficult for you because all the mail servers also run on that one also. Many mail servers there.
Yep.
So
Thank you.
to take care of that one. Okay, thank you very much. Any question? Thank you.
Thank you, Samajit. Last and certainly not least, GGM will talk to us about KSK TCR.
Hi, everyone. I am your nearest trusted community representative. Trust me with key signing. That's what we want to be. We want to be Lordy doing death metal. Unfortunately, when I went to be a rep, we don't have cute heavy metal costumes. We're a lot more like the guys on the right. We drink a lot. So the actual reality is slightly less hardcore, but a lot more metal. We spend a day inside this cage, performing highly scripted behaviors to enter a higher security zone, take articles out of a safe, conduct HSM transactions, and put them back in the safe. If you look at this picture here, see that guy? That's Carlos Reis from ICANN, who is also at the meeting, who is also a participant in this framework. All of this is mediated and facilitated by PTI staff and ICANN staff and VeriSign staff. And I'm here to tell you that I spent my day last year looking at this activity, watching them. They are extremely professional. They are extremely careful and dedicated. They are absolutely consumed by process improvement to deliver the best possible signing and trust in signing in DNSSEC. So that's my 2-slide presentation, and I could basically stop there. But I do want to tell you, without materials, a couple of other things. We're about to enter a window to begin a process to make a fairly significant change to the DNSSEC signing state. Previously, when we've done key rollovers, the last one was 2017, we've stayed inside the same algorithm family. We're in RSA 2048. And we are about to enter a world of doing an algorithm shift and go to ECDSA. And that has massive change for people. In the first place, a totally different crypto engine has to be used both for signing in the HSM and by all the relying parties worldwide. So this is potentially testing code paths that people haven't looked at. I don't think there'll be a problem, but you do need to be aware there's going to be a change in DNSSEC. The second thing is that the end point here is actually a long way out. The end point is 2030. So we're beginning a bootstrapping in 26 mechanistically with a key change happening in 27, leading to a final conclusion that we only have ECDSA in 2030. That's the kind of timelines we have to operate on. So why do it? Why do the algorithm change? Well, there is actually a massive upside, but it's kind of like a cost shifting. ECDSA produces significantly shorter signed objects, really radically shorter. So packet sizes in this data transfer are going to shrink significantly, and there is potential for that to improve reliability in the longer term of this service because there is potential for less large packet related problems to emerge in the DNS. But all good things come at a cost. And the cost here is during the window between here and there, we're going to have to send out packets that are twice as large because we're going to have to double sign things and send double payloads. And so there's actually a pre-state where we're going to reduce the length of a signed key from the current 2048 down to a 1536 key size to ease the growth potential for sending double-signed objects. So there's going to be some intermediary key change behavior below the KSK to create smaller signed products during a transition window. There's a second thing going on here, which is kind of a weird story. I mean, if you work in networking, you've been used to holding spares, right? Cold spares on the shelf in your own hands. Oh my God, we've lost the switch in Jakarta. I know, I've got a spare switch, I'll deploy it. So how long is an ACID on the shelf valid to deploy? What's the lifetime? Got a story about that. A friend who used to run an ISP pre-configured about 200 Cisco routers for a banking deployment, spent a day building the images, packaged them, sent them with the courier. He hadn't left them online long enough to charge up the NVRAM battery backup. And when they were arriving at destination 4 days later and unpacked, every one of them had blanked and reset to factory default. And he had to hand boot every one of these routers over the phone. So the HSMs, the crypto hardware that generates the signature, PTI holds spares. They hold them in these safes. The spares have reached end of life for the battery. And there's a cycle they go through to test and replace older hardware. And the last key round, testing one of these spares on the shelf, it wouldn't boot. It had zeroed. So we have actually reached the risk window where we have to do a technology switch, which in turn means inducting new keying materials, inducting new M of N, performing certain operations. And the guys from PTI and ICANN are now scripting for 2026 that we kickstart a number of activities to get rid of old hardware and institute new hardware. The new hardware, by the way, has a 10-year battery life, not 5. So there's a substantive improvement in that. So the real meat in the sandwich is that there's a public review open at ICANN. Now, you are all very smart people and you know how to use search engines. So if you have an interest in DNSX signing, key technologies, changing the key of the root, the process, there's a public submissions process that's open until April 2026. And I very much encourage you to go there and have a look. And in the meantime, if it's humanly possible, I think we should institute heavy metal key signing. But it's not going to happen.
Thank you, GGM. Any questions? Still got a bit of time. Yep. Jeff has one at the back. Yes, he does. You shouldn't be surprised.
You can't do this to me.
Jeff Houston, APNIC.
Sorry, please state your name.
Jeff Houston, APNIC.
Sorry, please state your name.
I was involved in the first KSK role.
Yep.
I've forgotten when, 2017. It was certainly dramatic in many ways. But one of the biggest issues was that there's kind of two keys in the root system.
Yep.
There's the key signing key,
Yep.
which is effectively under control these days of the PTI.
Yep.
And there's the zone signing key,
Yes.
which is under the control of the root zone manager, which is a role undertaken by VeriSign.
Yep.
The problem is those roles aren't coordinated. They're not. Independent bodies making independent plans.
Yes.
And one of the issues was that if the timing of the KSK was slightly skewed, you ended up with a root zone with 4 signatures
Oh,
at
man.
its peak.
Oh,
right?
man, Jeff, can we please not do that?
Well, the real open question here is, and I would encourage folk who are reviewing this plan, if they look at that, because it's all public, is to what extent is VeriSign and the root zone manager committed to play nicely, or do they think they're on an automatic 6-month roll that's not going to change for anyone, even a KSK?
Yeah.
The related issue is that when you change the algorithm, some resolvers kind of don't like a different algorithm for the zone signing key and the KSK. What work has been done on that, George, trusted community representative looking after this
Oh no,
KSK
the numbers
role?
are running down. I'm not going to have time to answer that question if I watch.
Plenty time.
You
Plenty
can't
of
do
time,
this to me,
George.
Mark. You can't do this to me. So I'm not here to say what should or shouldn't happen. I'm a process participant to say what I saw happen was visibly what was in the script that represents the best practice in the room. And I believe your question is both a valid question and, if you like, a meta question about behavior of complex systems and procedural boundaries outside in the room behavior, because you can enter the room and do the dance perfectly, and it's an unwise act. And I think your intent is, where's the review conversation about the wisdom and the processing to coordinate at a meta level? That's how I'm hearing it.
Well, the room is basically a sheet of ice, and I'm gently pointing out that it's not very thick ice.
Yeah.
And if you push it a bit hard, it's just going to shatter and break. And I was kind of wondering who's looking out for that.
So that's a question.
I'm not getting reassuring answers.
No, because I'm not the person who would do that. The question is one that should go into the ICANN Open Forum policy review process. What's it called? The submissions process. There's 55 days, Jeff.
But that's not the root zone manager.
But they're the ones, they're half of the
We've
two equations.
compartmentalised this entire exercise that no one is responsible for the whole.
So, Jeff, did you have a hat on raising this point?
No, I have a point of view.
People may not know that Jeff actually has functional roles in some of the security and stability area, or has he since left that domain?
Oh, that committee is not responsible for any of this. They merely sit on the side and throw objects at them.
Yeah, well, here's an object being thrown. It's a good question. It's a great question, Jeff.
That's why I asked it.
Yep. Have fun, guys. I'm leaving.
Thanks, GGM. Thank you all for your time. That concludes the Lightning Talks for 2026. Just some housekeeping. We will have closing plenary on time at 4:30 in this ballroom, so let's be back here for that. And then we'll also have the closing social at 6:30 at the Piazza, which is in the mall, 2 minutes walk from here. And that's about it. I think we leave early so we can get to tea first before everyone else. Thank you very much.
I just wanna